All right, the last question is about Hess's law. It says you use the standard reaction enthalpies given below to determine delta H reaction for the following reaction. So we have this reaction, and we're given this reaction, and we're given this reaction. Hess's law is the thing where we add the equations together in order to form the overall equation. In order to do that, we need to find what's unique in this equation as compared to this equation, and what's unique in this equation as compared to this equation. So how we're going to do that is we're going to just look and see which elements are unique. So if we look here, we have SO2, which is not in this equation. So we could probably ignore that one because it's not even here. We have sulfur and oxygen, okay? Oxygen is in both of these equations, but sulfur is only in this equation. So I know that my overall equation is going to come from the sulfur in this equation. So a couple things I need to check. First, I need to make sure, is it a product, which it is. And the next thing I need to check is, do I have the correct number? No, I only have one of these, and I need 4. So in order to do this, I need to multiply this reaction by 4, in which case I can multiply the delta H of reaction by 4. In order to do that, I need to simply take 4 of everything. So for reaction 1, I'm essentially quadrupling it. Okay, so I'm going to do 4 SO2 gas yields 4S solid plus 4 O2 gas. And again, the reason was 4 is I wanted to make sure that this was a product because this is the only one with S in it, and I wanted to make sure I had the same number of moles as in the overall reaction. So when I do that, I get this reaction here, which means the delta H of the reaction is not going to be this, it's going to be 4 times of this, which is 1187 kilojoules. All right, now let's look at the next one. SO2 again is not in this reaction. O2 is in both, so we're going to hope that cancels out. And SO3 is unique to this reaction because there's no SO3 here. So these are designed so they work, okay, and to be relatively straightforward. So we can just look at this SO3 and realize that this has to be from here because it's not in this reaction. So how are we going to do that? Well, again, I'm checking 2 things, the number and the side. So the first thing I notice is it's a product here and it's a reactant here. So I need to reverse this reaction. All right, if I reverse the reaction, I reverse the delta H of the reaction. Said another way, I make it positive 197.8. But there's another thing that I need to do. There's 2 here and 4 here. So I need to also double it. And remember, if I reverse it, I reverse everything. And if I double it, I double everything. So reverse and double. So instead of 2 SO3 as a product, I have 4 SO3 as a reactant. Okay, because I reversed and doubled it. This has to also be doubled and become a product, 4SO2 gas. And this has to be doubled and become a product, 2O2 gas. And now the delta H of the reaction, forget the H, okay, is reverse and double of this. Reverse just means make it positive. Double means multiply it by 2, which is positive 395.6 kilojoules. Now, let me make sure this works by adding the reactions together. Adding chemical reactions seems complicated, but it's really not. Just write all reactants on one reactant side and all products on one product side. So 4 SO2 gas plus 4 SO3 gas yields 4S solid plus 4 O2 gas plus 4 SO2 gas plus 2O2 gas. So I simply wrote both of these reactants on a single reactant side and all 4 of these products on a single product side. Now, what I need to do is combine or cancel out like terms. So the first thing I notice is I have 4SO2 on this side and 4SO2 on this side. So nothing changed, so that can go. The other thing I notice is I have 4O2 and 2O2, which is a total of 6O2. So if I simplify this, I get 4SO3 gas yields 4S solid plus 6O2 gas, which is exactly the overall reaction. Well, if I added the reactions, I need to add the enthalpy of reactions. So 1187 plus 395.6, and when I add those together, I get 1583 kilojoules as the overall delta H of the reaction. Again, I just added these because I added the reactions together, and because enthalpy is a state function, you're allowed to do this. Essentially, question 18 is just a different version of Hess's law that's a little easier to use. So this is our ultimate answer. These problems are quite tricky, and at most there'll be one on the exam. All right, so I appreciate you watching. I know this one was a little bit long and complicated. I also hope that you would write down a cheat sheet for all the formulas that you didn't have memorized as we went through this problem set. Thanks for watching.